Okay, let's get started. So welcome everyone. We're going to start with trig graphs today, and we're just going to get our brains in the trig graph mood by starting with this multiple choice question. So what is your answer for this very first question on trig graphs? Also, I want you to make sure you have your calculator ready. So because trig graphs, your calculator is your friend, and so I want you to make sure you have that ready. Okay, and vote in the chat, please. What is your vote going to be? I'm going to draw this graph just so we can have some fun. 1, 2, 3, 1, 2, 3. In fact, it probably needs to go higher. So what do we think what effect does the transformation y equals sine x plus 3 have on the graph of the original function y equals sine x? Well, the original sine x will only go up to 1 and down to -1. So if you want to imagine a normal trig graph for sine has a period of, so what does a normal sine graph look like? It goes like that. Oh, wait, let me try again. So up to 90, down to 180, down to 270, up to 360. That would be a normal sine graph, right? Y equals sine x, although it should end over there. Oh, you can't see anything. Oh, okay. Well, let's try again then. Let me do this. So try again. It's window. Give me a happy face if you can see or a thumbs up if you can see my okay, we're back in business. Apologies for the delays. So A, B, C, or D, what do we think? Well, here is what the graph of y equals sine x plus 3, and you can even put this into your calculator if you need to, but basically it's going to start at 3, and then it's going to go up 3 more units. In fact, let me use a different color. So I'll go, that's 3, 4, 5, 6. Then the graph of sine x plus 3 is actually going to go kind of like that. So which of the options do you think? Oh, I lied. I tell a lie. I tell a lie. I have assumed that there was a 3 in front. That's not what happens. Oh my goodness, everyone. Can you see my mistakes? I'm sure you must have realized. Okay, so if it's going up by 3, this graph simply goes up by 3, but the amplitude hasn't changed. It just goes like this. Goodness gracious. Clearly, it's been a long day. Okay, so this is the graph of y equals sine x plus 3. Give me a thumbs up if you agree with my sine x plus 3 graph. So what's happened is this whole graph has moved up by 3 units, and so the correct answer is B. So when we talk about trig graphs, there are a couple of different changes. The one change that is in the front, and that's what I originally thought it was. I don't know why, but that number in front is the amplitude, and that will stretch it. And then if we go like this, then there are other things. So if that's the amplitude, the one that was used here is the vertical shift, which is the D. And then can anybody remember what a number does if it was just in front of the X? Let me get rid of that, actually, sorry. So what does it do if it's just in front of the X? What would the B do? So this thing over here would change the period, yeah. And what about this thing over here? What would it do? So this would shift the graph left and right. So that would shift it left and right. This last D is up, down. This one is stretch, stretch, up, down. And then B would be period change. Okay, thumbs up if you're familiar. We call this transforming trig functions. Give me a thumbs up if you've seen all these 4 transformations before. Okay, and also there is something called a reflection, but we'll cover those later. Okay. Oh, here we go. Okay. What effect does minus cos x have on the graph of the function y equals cos x? It's good to have the basic cos graph in your head just as a reference. What does the normal cos graph look like? It will look something like that. Now, what does a minus sign in front do? Well, if it was 1, it would become minus 1, so it would go here. And if it was minus 1 before, it would become 1, so it would go up there. So the graph is going to look like that red one. So which option do you think is correct here? Is it A? Is it B? Is it C? Is it D? I'll give you a hint. It has to be a reflection. Now, if there was a negative in front of the x, it would reflect it over the opposite axis, which would be the y, but there isn't. So what axis does it have to be reflecting like over? In fact, visually you can see it. What axis is this axis over here? It's the x-axis, yes. And so you would reflect over the x-axis. So in addition to the 4 transformations, if I change the sign, the negative and the positive, you can reflect over either the x or the y-axis. Oh, I see lots of students have joined us. Welcome, everyone. I will welcome you in a moment once I... Okay, now, which of the following points do not lie on the graph? So they're asking which ones do not lie on the graph. And you need to tell me. Welcome to Alexa and Buchle and Mateo and Naledi and Jabulo, Pabalelo, Pila. Who else has joined us? Sisipo, Siamtanda, Tamia, and Tandiwe. It is awesome to have you with us today. We are just getting stuck into trig graphs, and we're going to also move on to trig equations shortly as well. How do we test if a point is on a line? We check if we put it in, does it hold true? So is 1 equal to the sine of 90? You can check this, it is. So that's true. So it's on the line. It's on the graph. So it can't be that one. Is 270 minus 1? Okay, well, if I put minus 1 in my calculator, I get minus 1. If I put the sine of 270, I also get minus 1. So it can't be that one. Do you know what the answer is yet? Maybe I can help you with a graph of sine x. Doesn't the sine graph just look like this? Where that 0, that's 90, 180, 270, 360. Which point does not lie? So 270 minus 1, I can see it over here. The sine of 270 minus 1. Oh, I've made a mistake. I've made a mistake again. Oh my goodness. It almost caught me up because I was like 0 is on the line too. 180, 0 is correct. The answer is 190. And the reason I didn't see it was because my brain was telling me it was 91, which is this point over here, but it doesn't say that. Sneaky, sneaky. Do you all get the A? Give me a thumbs up if you Didn't get caught out by the sneakiness? Or give me a thumbs up if you are with me. See how teachers can be so sneaky, yeah? You're gotta watch yourself there. Okay, still in the warm-up. Let's go to the next one. Let's see if we can do better on this one. Which of the following points does not lie on the graph of y equals tan x? I suppose a quick way to do this is just to check what is tan of 45. It's equal to 1, so it can't be that. Tan of 0 is 0, so it can't be that. The tan of 180, let me check. The tan of 180 is equal to 0, so the correct answer must be C. And that's because I know why this is. The tan of 90 is error, or it's an asymptote, and so it can't have a value. It's undefined. Remember, tan graphs have that weird shape. Just so I can remind you, tan graphs have this weird thing where their period is also different. So for a whole tan graph to happen, you only need 180 degrees, and it has kind of this shape that's like that, and then it will just repeat itself every 180, and so you're going to have these undefined asymptotes there. Okay, according to the graph, what is the value of the cos of minus 60? This is, in fact, a cos graph. So y equals cos x. This is what the graph looks like. And let me show you your options. Okay, so we go to the cos of minus 60. Where is minus 60? 1, 2, 3, 4. So I guess, are we going up in quarters? A quarter of a 90. So 90 divided by 4 is 22.5. So that's minus 50. Minus 60 is going to be around here somewhere. And if I look across here, it's definitely above 0.5. So it can't be either of these, and it can't be that, so it must be C. It looks like it's about 0.6 something. Root 3 over 2 makes sense to me. Okay, now just for, no, actually, let me go on to the next question. Let me not get too excited here. Okay, according to the graph below, what is the value of the cos of 120? A, B, C, or D? What do you think, Pafunzo, Pabelelo, and Jabulo? What do you think? I see lots of people saying A's, or is that the previous question? Where is 120? So, okay, these are quarters, so that'll be about 140. So that's gone too far. 120 would be about there, because that's like 110. So yeah, 120. So it's going to be a negative. So do you know what? Since all of these are positive, and I can see it's 120 is negative, I don't really have to think too much. But you can kind of see it's at negative 0.5 or negative a half. Oh, I went a bit quickly there. Are there any questions about this? Or give me a thumbs up if you understand how I got the cos of 120 is negative a half from the graph. Maybe I should give you another one. I'm going to make up my own one. What is, using the graph, the value of these three? The cos of 180, the cos of the cos of 0, and the cos of minus 360. I want you to use the graph to help you find those. things. The cos of 180 is indeed -1. What about the next two? Cos of 0 is 1. And what about the cos of -360? Okay, it's also 1. Yes. And you can actually see that they're 1 period apart. Look, here we go. The graph repeats itself every 360 degrees. You can see that's 1 period's worth, and then it's 1 again, and then it's 1 period's worth, and it's 1 again. Okay, so we have this repeating pattern with trig graphs. Oh, now we're going to get some trig equations here. So remember, there's a method we can use, and there's this thing called the cast diagram. We have a 3-step process that we sometimes use for solving a trig equation, but you can also solve it by visually looking at the graph. Where is the sine of x equal to 0.122? And you have to tell me where it is, and the answer needs to be in the domain 0 to 360. But that's fine, because there's the 0 and there's the 360. So is it going to be A, B, C, or D? And we have to use the graph this time, and then I'll do it by theory afterwards. Where would 0.122 be? So that's a tenth, a little bit more than a tenth. So I think to visualize this, my straight line is going to go like that. And it feels like the sine graph will be equal to that number at those points. Does that help you get an answer for A, B, C, or D? I want to see some voting. I'm not seeing enough voting, so I know if students know this. So for me, the biggest, this looks like it's about 7, right? I don't know exactly, but I know that it can't be bigger than 180 because there's 180. So this is out of the race. This is definitely out the race. This is definitely, and this is B. Now, let me show you using theory how this would work. If we were solving this equation using our algebraic method, we would find the reference angle. And if I go shift sine 0.122, I get a reference angle of 7.00, or 0.1 if I was actually, but that's fine. Now, in what quadrants is sine positive? It's positive in quadrant 1 and 2. And what we find is that if something is in quadrant 1, it's just going to be the reference angle. If it's in quadrant 2, it's 180 minus the reference angle. And so we would say here, x is 7, or x is 180 minus 7, which is 173, which is what they got here. If I wanted it to be a general solution, I would just add on the k times 360 here. Give me a happy face if you understand the connection between the graph and the method that we're using over here. So I'm going to do more of these examples, but I'm just wanting to reinforce this idea as we get going. Okay, here is your next question. Now you can use the graph or you can use theory, but you need to solve this equation. If cos of x equals 0.64, and I'm looking for the domain 0 to 360, which of the following 4 questions would be correct? Okay, let's see. 0.64 would probably be about here somewhere. And I noticed that that looks to me like it's in the, if I look at the answers, that probably is the 50 over here. Now, what I notice is that it has to be greater than 300. And so I can exclude all of these. And the correct answer would be B. Now, if I was doing it in the three-step formal process, I'd get a reference angle would be equal to 50.2. And then the answer, when is cos is positive in that quadrant, in that quadrant. And that's why we have the answer where x is 50.2. But in quadrant 4, it's always 360 minus the reference angle. And that's why we have this part 309.8. And you can check this. If you put in your calculator the cos of 309.8, you should get your 0.64. So that's how another way that you can check. Give me a score out of 10 for how well you've been understanding the trig graphs we've been doing so far. I'm going to make it harder, but I just want to get a feel for if you're feeling comfortable or like you're in the middle or you feel lost. And remember, I can't see your faces, so you need to be brutally honest in the chat. Otherwise, we're going to play broken telephone. We don't want that. We want clear telephone. We want communication coming through nice and clearly. Okay. Which of the following gives the equation of the graph below? Thank you for your votes. Cullen, Bukle, Naledi, Sisipo, Tandiwe, Tamia, Bukle, Akwande. What type of graph is this? It's going up and then down and up. Oh, this must be a sine graph. Okay, but now there's all these ones floating around. What do I think's happened? The normal sine graph, I remember from earlier on, looked like that. So what equation describes going down by 1 unit? It's just going to be this. It's not this one. Don't be confused because the 1 needs to be outside the bracket. Okay. Let's just do a couple more multiple choice questions and then we're going to go to some old papers. So, number 1. Is it going to be A, B, C, D, or E? When is the graph of tan not defined? Remember what the tan graph looks like? What are these values over here? I remember this being minus 90, that being 90, but now I don't see anything that matches that. So let's see if I can draw another tan graph. So when would the next undefined part happen? Oh, yes, I know what's happened. They've used another period of the graph, and the period of the tan is 180. So the correct answer would be, they're basically asking for that and that one, which is D. Is there anything else that I'm missing? No. Oh, they only said for the domain 0 to 360. That's why we're ignoring that one. Okay. Number 2, what is the period of the graph y equals sine a half x? What is the period of that graph? Now, we know what the normal period of the sine graph is, but that's not what it's asking. It's asking what's the period of this graph? Okay, now how do we change the period of the graph if we've got a different number in front of the x? We go 360 and we divide it by the number in front of the x. So what is the period going to be? Well, use your calculator if you have to. What do you get? I get 720, which is C. And just to give you a sense of how this graph would look different to the one you're used to, normally you are used to, if that was 90, 180, 270, 360, and that was the sine graph, and it would go up to 1 and down to -1. Now, because the period has doubled, instead of going up to 1 in 90, we're going to go up to 1 in 180 and then down to 360. And that's why the period is now 720, because it's basically taking longer to get through a whole cycle. Give me a thumbs up if my little drawing helped explain what the 720 period looks like. Okay, so what you need to remember is that to get the new period, you take the old one, divide it by that number, and you get the new one. Okay, I've lost quite a few of you, so let's just do another example just to check this. If I said to you, what is the period of this graph? Y equals sine 3x. Could you work out the period of that graph? You can just give me a number. So you take the normal period and you divide it by 3, and so the new period would be 120. Give me a thumbs up if you got the new period for that made-up question was 120. Okay, now how would that affect the graph? Well, and we're going to draw graphs soon. We're just going to take a break and then we're going to draw some graphs. If the period is 120, the step size for drawing the graph would just be 120 divided by 4, which is 30. So we draw it in quarters. And so if this graph was being drawn, if that was at 30, 60, 90, 120, and so on, this graph, sine of 3x, it would go up to 1 in just 30 degrees. Then down, let me try that again. Then down again, and then up. Boucle, let's go to you. What is your question, Boucle?
So how do we know, like if we get a question like this in the exam where the period changes and becomes whatever, how do we know what interval we're going to use for
You.
drawing the graphs?
Okay, it's a very good question. So basically, I would call it the step size. And when we draw graphs after the break, we're also going to use our calculator to help us. But Boucle, what you do is once you've worked out the period of the graph, say like we've worked out the period of this new graph is 120. If it's a sine or cos graph, we divide it by 4 to get the step size, because these graphs are drawn in quarters. If it was the tan graph, we take the period we've worked out and we divide it by 2, because the tan graph is drawn in halves. Does that make sense? Okay, awesome. Okay, you know what we need to do? We need to take a break. We're going to come back to these shortly, I promise, but too much work and your brain, you don't take care of your brain and it gets upset. So I want everyone on their feet. I want you to join me as we just unwind so we get the best quality maths today that we can. And we're going to start by breathing in, hold at the top, and then breathe out. It's like this. Feel a nice rush of oxygen. Breathe in. Breathe in. Last one. Okay. Then what we're going to do is we're going to loosen up. So we're going to shake our arms around like we're like a puppet on a string. And we're going to shake our legs. Okay. And then I want us to roll our arms. Roll them back. And then roll them forward. Like that. Okay. Let's do a little stretch to the side. And then what I want you to do is put your arms out and just rotate. Just gently. Kind of like you're a windmill turning around, I guess. Okay, last thing we're going to do is we're going to get some blood flow. So this is what's called a jumping jack. And we are going to do 15 of those in 3, 2, 1. Let's go. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And let me know in the chat, how are you feeling? My heart is pumping, but I know that my brain is like, you know what? Because you took care of me, I am going to give you another 25 to 30 minutes of concentration. So thank you for taking care of me. Okay, I think we're learning quite a lot through these multiple choice questions. So I just want to just carry on with them just for a little bit because they don't take very long. What is the period of the graph y equals 2 cos 3 theta? What's the period of that graph? Vote. Put your answers in the chat. What do we think, everyone? So the normal period of cos is 360, but it can't stay the same because of this 3. So the new period is going to be 360 divided by 3, which is 120. And so the new period of this graph would be 120. If I was drawing this graph, I would use a step size of 30 degrees because I just take this and divide it by 4 into quarters. That's what I was saying before the break. Okay. Which graph is represented below here? So I'm doing number 4. I just can't exclude number 8. Which graph is represented here? What should we be looking for with these trig graphs? I see that the highest it gets to is 1 and the lowest is -1. So that should help me know what has changed and what stayed the same. I only see 0 and 120. So that also must tell me something. Is it a sine graph? Is it a cos graph? How would I know that? What do you think? I'm pretty confident that it can't be this one because that would stretch it up, and it can't be that one. I'm pretty sure it's not this one because the sine graph starts by going up. So it's either none of the above or B. Okay, this graph would have a period of 120, which this does, and I'm feeling like it's B. Yeah, it's B. It's the only one that would fit. Thumbs up if you got that. Thumbs down if you were like mystified by how I got that. Okay, let's see. Okay, let's just do one more multiple choice. I do love a good multiple choice question. Can you tell me what the range is of this trig function. And what I'm going to ask you to do is I'm going to ask you to use your calculator now, because we're going to start drawing. So on your calculator, I want you to hit mode. So we're going to answer this question. So mode, and then I want you to hit 3 for table. So 3 for table. And then I want you to type into your thing, it goes f of x equals, and you're going to put 1 plus sine x. So 1 plus sine, and when you put the x in, you need to use alpha and then the thing. And then you're going to say, where must I start? Well, I'm going to start at minus 360. So I put minus 360. And then where am I going to end? I'm going to end at 360. And now what is my step size? Well, has the period changed in any way? No. The normal period is 360 of the sine graph. So I divide it by 4. And my step size is 90. Now, if I look at my table, there's a table of data. Type table in the chat if you've got a table of data now using your calculator, where it starts at minus 360 and it has 1, and then it has minus 270 and it's 2. Type table in the chat if you've got that. Okay, now, how can this table help us figure out what the range is? Well, I'm just going to look through my table and find what is the biggest number. And so far it's 2, but let's see if anything gets bigger. No, the biggest number is 2. What's the smallest number? No, the smallest number is 0. I can't see any negatives here. So what is the range going to be? Well, the range has to be between 0 and 2, which means the answer is C. Now, we're going to move on now to drawing some trig graphs, but have your calculator ready to help you get to them. Okay, so let us go to drawing some trig. Let's just leave that one up for now. Let us draw. Okay, here's a past exam paper question. So we are going to draw these two graphs. And first of all, we need to see what is the domain on which we are drawing them. Well, it's minus 180 to 180. Here's my minus 180 to 180. The first graph I want you to draw is f of x is cos 2x. Can you tell me what has changed about that graph? What sort of change has happened? Okay, so the period has changed. It will, instead of being 360, the period would now be 180, which actually is what they ask about here. Okay, I want you to draw this graph using your calculator. So I'm going to give you 2 minutes to do this. All you need to do is go to table, then you need to type in the function, and it's going to be cos 2x. You need to do the start, which would be minus 180. You need to do the end, which would be positive 180, and you need to choose a step size. Now, this is tricky. What's the step size going to be? Okay, because the period changed, so the step size is going to be 45. Okay, draw me my graph. And then after you've drawn this one, I want you to also use your calculator to draw me this one. But remember, you're going to have to key it in again. So I'm going to give you actually 4 minutes. I'm going to give you 4 minutes to draw both these graphs, and then I'm going to come back and do it with you. Okay, so I've drawn, just to help you, the graph of f, but you still need to draw in for me the other graph. And while we're all doing that, if you have a question you'd like to ask, now is a great time. Don't forget to close your bracket when you add the, after you over here and you have to add 1, you must make sure you close your bracket there. And then start minus 180, end positive 180, step size is 90. And what I sometimes like to do is put dots. So minus 180 minus 1 is there. Minus 92 is here. Then it's 0, 1, which is there. Then it's 90, 0, which is there. And then it's 180, 1, which is there. Okay, so normally the sign graph goes up, but this is going to be like plus 1, yeah, because this is going to go. No, wait, how's this going to look? Normally the sine graph would go up, so, and then it would go, because it's reflected, it's going to go down. So from here, it should go, normally it would go up, so now it's going to go down. Yeah, that makes sense. But then this is going to go, oh, I hope I'm drawing it right. And then this one over here, what's going on? Have I done something wrong here? What have we got? Minus 0, 1. No, that's correct. Give me a thumbs up if you got the same numbers as me. The same points over here. Actually, I can bring up the answers here. Let me just bring up the graph here. Oh, okay, it's not there. My only thing I'm debating for myself is with whether or not, so normally the sine graph would go down here. So here, because it's been reflected, this would go up. And then over here, it should then go like that, which is a bit weird. Up, down, down, up. Okay, that is roughly what we're going to get. Oh, you didn't get the same answers for g of x. Okay, well, let's just check in my, I'll draw this in again in a moment, but let's just check our data. So for g of x, I'm getting, in my little table, it should start at minus 180. So minus 180 minus 1, minus 90. Oh, minus 91. Sorry. So minus 181, minus 92, 0 is 1, 90 is 0, and then what have we got now? 180 is 1. Give me a thumbs up if you all got that. Okay, so those are the dots over here that I was using to connect them. So normally it would go like that. Okay, let's answer the questions. For which value of x in the interval will g of x minus f of x be the biggest? Can you all see where the biggest gap is? I think the biggest gap is over here. So when is the g of x minus the f of x biggest? So just to check that I've labeled my things correctly, that was f and this is g. So the g of x and the f of x are far apart here. So the answer for this should be minus 90. Thumbs up if you're with me. So let's just test this out, because if this works, what should happen is, if I take the f of minus 90 and I minus the g of minus 90, then I will get sorry, it's the other way around. If I get g of x, so g of x minus f of x is just saying, look, what is the distance, the y value of the g graph minus the y value of the f graph. And in this case, at minus 90, the g is at 2, and then the f is at 1, so you get 3 now. Okay, if the graph is shifted, if the graph of f is shifted 45 units to the right, what will the new equation of that graph be? So currently, f of x is cos of 2x. What will the new equation be if I shift it to the right by 45? Remember what horizontal shifts deal with? Which number was I dealing with? So h of x, so they said refer to as h. Now, I'm still going to have the period change, but something else has to happen. I have to go x, and something has to happen to shift right. What should I do? To shift to the right, I need to go minus 45. So it's a bit confusing because people think, oh, if I'm going to the right, but it's the opposite of your intuition. The other thing sometimes people do is they forget that it needs to be inside a bracket, so they might write that. That's also wrong, because the period change essentially happens after the shift. And so you have to put it inside that bracket like that. Okay, let us move on and just squeeze in one or two more things here. Okay, so this is another often. Okay, we're not going to have. Okay, we suppose we could. All right. If we look at this as a typical question, what they've done is they've combined two types of questions. So they've said here, write down the period, write down the range. You can use your calculator to help you with these questions. Then you have to draw the graph, which you can do. And then they ask about intersection points, which is basically where they meet on the graph. What I want to work on is this last one here. Now, this is a bit harder than the typical general solution question you get. Why is this a bit harder? Who can tell me what makes this trig equation harder? And how do we deal with that difficulty? Any ideas? What makes life so difficult, this one? Yeah, so okay, sine and cos in one equation, exactly. So I want to do my lovely three-step process, but the problem is now they've gone and put two flipping different trig things together. How am I meant to deal with that? Okay, now there's a secret little thing I'm going to show you. Isn't there a thing that says the cos, well, if I want to change from sine to cos, can't I say the sine of x is the same as the cos of 90 minus x? Or if I want to change from the cos of x, I just say it's the sine of 90 minus x. That's called a co-ratio, and we spoke about that in reduction formulas earlier on. So if I say to you, I've got the sine of 70, it's the same as the cos of 20. Give me a thumbs up if you remember this trig identity. Okay, now, what I think I want you to do is I want you to change this side of the equation to be in terms of cos. Can you rewrite the sine of x minus 30, but I want you to write it as a cos? Can you do that for me? What would you get? Or if you'd like to, you could also rewrite the sine or the cos as a sine. So would you prefer that? Should we have a vote? So 1 for if you want to change to cos, 2 if you want to change to sine. I will let the audience decide. So 1 is change everything to cos, 2 is change everything to sine. Which one would you prefer? Okay, the ones have it. So we are going to change the sine of x minus 30 to cos. Oh, I know what we're going to do. We're just going to go 90 minus x minus 30, because that was the angle there, which is now the cos of 90 minus x plus 30, which is then the same as the cos of 120 minus x. I know, what a mouthful. But are you with me so far? Can you see how I use my 90 minus trick? Okay, why does this make life so glorious? Well, now I have 120 minus x is equal to the cos of 2x. Why does that make me so happy? Well, this makes me happy because now I work in only causes. It's not causes and sines. So this is fantastic news. But now the question becomes, how do we deal with our three-step process? And also the reality that there's going to be two solutions. Now, I think a lot of you can see that I can drop both causes and do that. That would be my quadrant 1 solution. But there's also going to be a solution for quadrant 4. And that's going to be the second set of solutions. So I'm going to pull up the memo now because we're running out of time. Let's see if I can just bring it up so I can actually talk you through this process, because it's a bit of a tricky one. Okay, so as we look at the memo here, let's just see if we recognize. Do you recognize what's going on over here and what's going on over here? Okay, now what we're going to do is we're going to say in what quadrants is cos positive. Cos is positive in quadrant 1 and quadrant 4. Now they're doing it with the plus minus idea. So you can also do it like that. So basically, instead of doing, some textbooks do it like this, instead of saying this is the reference angle and this is 360 minus the reference angle, they just say that another way of saying it is that it's the reference angle and minus the reference angle. Okay, so step 1, what do we do? We say 120 minus x, which was over here, is equal to just 2x. Why did I do that? Because they both have cos, therefore these two must be equal. And since it's a general solution, I have to have my k times 360. Give me a thumbs up if you understand how I can just drop the causes because they're both the same, and we go like that. Okay, now we're going to do some algebra. I'm going to move the 2x to the other side and the 120 to this side, and I'm going to get minus 3x is minus 120. I think all of you will get that. Then I need to divide both sides by minus 3, and I get x is 40, But notice how it's now k times 120. And the reason is the 3 needs to divide not just that, but also this thing over here. Okay, now, what is going on this side? We have to get our second solution, and all that they've done is they've still got the 120 minus x, but they've written minus 2x. You could also write, instead of minus 2x, you could just write 360 minus 2x, and that would also work to give you the second quadrant solution. So 360 minus the reference angle, so you could write that, or you can just write minus the reference angle. And then what happens? Well, this is just going to go to the other side. So what's 2x plus x? It's x. If I bring this to the other side, it's going to be x is minus 120 plus k times 360. I think a lot of you would struggle with this, but remember, if you didn't do this, you still would have got 4 out of 5. So there's no use going over the top on that question. But I just did want to show you like a slightly harder one. Okay, we're not quite finished with trig equations.